comes, if you're busy, you at least have everything done. So again, I'm going to help you with that. And again, go through the practice exercises with you and optional exercises that are kind of in the format that you will experience with the midterm and final exams, so that you will feel more comfortable, because it can be nervous, it can get you anxiety when you know you have a test. So I will give you lots of review material and always the topics. So understand the topics. There is a lot of material, so you may have to just read it again and again and again until you get it. There's no other way to do this. It's not something that you're born knowing. It's something you have to learn. And if you're new to system software, it may be a little challenging. But again, you can work together on all of this. Just don't give everybody the answers before the assignments are due. But you can work with each other so everybody understands everything. Okay, so Chapter 3, we went over the process concept, and Chapter 4, multi-threaded programming. We started looking at code, starting to understand coding. The exams will be created by the school. They will be using exam questions that are typically with the textbook. So they'll be very similar, or cover the material that you see in the exercises at the end of the chapter, and multiple choice, true, false type of questions. So it will be something that you will have some study guides. I will be giving you all these slide presentations, have example questions for you to study and know, and also your homework assignments can help you to study and know. But you are responsible for all the material, so the only best way to know all the material is go through the topics, make sure you understand each one, and understand the exercise questions. The exercise questions are kind of the material that's similar to the exam questions. So it's not something I will be doing. It will be created by the school for you, because we have various sections. So everybody this way, every section of this class, there is more than one. So this way they all have a standard exam, and everybody has the same exam. You're welcome. Okay, Chapter 3, we went over the process concept. A lot of you understood it very well. Process scheduling, we touched upon it. We're going to go over that in depth this week. Operations on processes, that kind of was very clear. Once you bring it into the world of programming, then you know you have to create it, and then you have to delete it, and then you have your different classes and methods and attributes that you work with. And then we talked a little bit about how processes communicate with each other. There are various strategies. They can share the same message space, or there was a message board. So different strategies that different operating systems use. But since this is just the basics of operating systems, you kind of look at all of the things that current operating systems use. There are examples, and we talked about client server, and then many of you mentioned that you are already taking a class now or on networking, so you kind of have some understanding of client server technologies. And that's just again, another strategy, another model that is used and is heavily used in the internet world or in any kind of workplace networking. They all now emulate the OSI model. So do look up OSI model, and you could know more about how client server works, or communication in general. So that's the OSI model. Okay, Chapter 4. Now we started talking about programming. We looked at the differences between processes and threads, what some of the operations are to create a new thread. There was the fork, or create a new process. There was the clone. Thread libraries. We looked at hierarchies and libraries of threads, implicit threading, threading issues, and operating system examples. So again, go through that material, look at the topics, here to see if you understand it, or you can right away give some brief summary and description. Writing that out would be a good study guide that you create for yourself. And also to also look at the exercises at the end of the chapters. Okay, here's our assignment questions that we had for week 2. Exercise 3.2, describe the actions taken by a kernel to context switch between processes. So hopefully you were able to understand the context switching strategy and how it was used. And this is the answer generated for this question. Some of you went into great detail and more detail, which is fine. Does anybody have any questions on this question? So in general, the operating system must save the state of the currently running process and restore the state of the process scheduled to be run next. This is the strategy. It's like the current process and process coming up. Saving the state of a process typically includes the values of all the CPU registers in addition to memory allocation. Context switches must also perform many architecture-specific operations, including flushing data and instruction caches. So that's just the strategy that's used to keep track of the instructions of a process. It can't mix it up. It's a process manager. And when it's a process manager, it has to keep this information about the processes. And context switching is the way that the kernel does this. So hopefully you do understand this, and if you have a question like this on the exam, you'll be able to answer it with multiple choice. Next exercise. Here's explain the circumstances when a line of code marked printf, line J, in figure, is reached. Here was the answer. Here's the code. Let's look at this code. Now, hopefully with any coding programming that you've done, you kind of can mentally trace the way a program functions. You should already know the basic statements that are in a program, such as PID equals fork and in parentheses. That means fork is a method that does something, and then it returns a value, and that value is stored in PID. And PID stands for process ID. Now, it checks. This is called error checking and error handling. Whenever you create a program, you should always anticipate possible errors that may occur. And in your code, you must address these errors so your program doesn't crash. So it's a good strategy that you should do no matter what kind of program you write. We will look at some of this when we look at Java, or maybe you have already when you've taken your Java courses. But this is true for any programming language. You have to anticipate possible errors. If this doesn't happen or if this doesn't happen, it's not always going to run as smoothly as you like. And if you don't do something about an error, if it occurs, then your program will crash, and that definitely is not a good thing. So we now have these different values for this process ID. If it's less than 0, that means there's an error. So that means that fork, a process was not able to be created. If it's equal to 0, that means a child process was created, and then the line J will be printed. Else, it may be waiting for a child to complete. So it all depends on what stage of the process execution all of this is in. So are there any questions on this? Now, I also brought up that this exec LP, there are various versions of exec. I did post a link to it, so look at the different versions. This is just one that we are looking at. But I did mention before, when you're learning a programming language, that you should always go to the API reference library, because it gives you more information. You may think that exec LP is the only one that exists, and that's not true. There's more versions of exec. Same thing with printf. You may think printf is the only one that exists. No, there are many versions of the print. So that's why you should always go to the API reference library to know all these different versions. And this obviously is, when you see .h, the include file, then you know it's a C programming language. So you would go to the C API reference library. Or just type in, or Google exec, and then you'll get the different versions. Any questions? So do you feel comfortable in actually understanding what a program does? I think the if statements are very clear for you. You understand what an if statement is and an else statement and what it means to call another function or method. Like fork, it always will have parentheses, so you know something's being called. So any questions? Are we good on this? So this is the answer that came with this exercise. The call to exec replaces the address space of the process of the program specified as the parameter to exec. If the call to exec succeeds, the new program is now running and control from the call to exec never returns. In this scenario, the line printf would never be performed. However, if an error occurs in the call to exec, the function returns control and therefore the line printf would be performed. Does this make sense? Any questions? I'm not hearing anything, so that means you're all good? Okay. If you have more questions, then again, we can always work on this. We will review this again when it comes to midterm exam. Okay, here's another one, optional practice, page 147. This was another one. What output will be at line A? So let's look at this program. Value is 5. Then we do again, PID equal fork. If PID equals 0, value plus equal 15 returns 0. Else, if PID is greater than 0, wait now, printf parent is the value. Now remember, it's only in the if statement that the value gets changed. The else statement does not change the value, so it has its initial value, which is 5. So the answer to this is the result is still 5 as the child updates its copy of value. When control returns to the parent, its value remains at 5. This illustrates very clearly the difference between local and global variables. When a child has a variable, it's going to be its own copy of that value or that variable. So it makes changes. So when it comes back to the parent still has the original value, and the original value is 5. So that means you may want to review the local and global variables between parent and child processes to understand actually how all this works. But if you, again, looked at functions or looked at methods, when a method has a copy of a value, it changes that value, but it does not change the global value. It's only changing its local copy of that variable. Okay, here's another one. How many processes are created? Now this, I did have someone answer that. However, there's actually 8 processes that are created. Yes. Now you would think it would be 4. However, there is a trick to this question. What it means is when a child, and there's another call to fork, that child then becomes a parent's child. So it's not only, it's a child for its previous parent, but it's a parent itself for the next child. So I kind of put, you know, you have your parent 1, and then child 1 is created, the first call through the fork. But then the next call for that fork, that child 1 also becomes a parent. So then it's kind of considered another process. So then when that fork is called again, the parent, that child 2 becomes a parent, and then when it's called again. So it is called 4 times. However, because a child becomes a parent, it's considered another process. So that's why it's actually 8 processes that are created. Okay, so we know now, remember when a fork is called, if a fork is called within a child, that child then becomes a parent. Okay. Okay, good enough. Okay, now exercise 4.11. This was another one comparing modeling processes and threads within the kernel. What were the options? Well, on one hand, in systems where processes and threads are considered as similar entities, some of the operating system code could be simplified. Remember, there was a difference. Are they separate, completely separate processes or not? There was a difference. When some operating systems, so that when another thread is created, is actually another process. Some is considered a thread and within the same memory space of the parent process. So all of you pretty much understood this and did get this information. So again, it's just strategies on the utilization and naming of the spaces that are used. Is it a completely new memory space? Is it a shared memory space? That's what makes the difference here. Any questions on this one? Again, if you're struggling with it now, you will get it. Just keep rereading it again. And again, I've been mentioned before, if you don't understand your textbook, go on the internet and look for another person explaining the information. There are other books out there, other authors, other websites that maybe explain the same information, but in a different way that makes more sense to you. You know, just because you're not understanding this author or these authors doesn't mean you don't understand the topic. It just means they're not explaining it properly or explaining it in a way that makes sense to you. So go find another author who explains it a little differently, but then you'll have the same idea in the end. And also work with each other to explain from each other. Sometimes, you know, your classmate can explain it where you understand it because they know you or they know how to explain it, so you will understand it. Okay, here's some more. These were some example questions I gave you as well. I don't know if you did do them. They were in the slides. So we'll go over the answers now. So this is from Chapter 3. The blank of a process contains temporary data such as function parameters, return addresses, and local variables. What's the answer? Anybody? We're going to do a little question and answer. I'll give you the answer. No, we're almost there. There we go. You should get a prize. We're going to get a cook. Whoever said D stack should get a cookie or a star. I don't know. I can't give you a cookie over the internet. Yes, it is D. There you go. Now let's look at this. Okay, program counter. Program counter is just to count different programs. The data section is what? Information about the resources and data. So if you just, but in general, all this information is in the stack. So it's put up through a stack, and that's the strategy that is used. And again, if you want to review this information, it's in section 3.11. Okay, next question. The process may transition to the ready mode by which of the following actions? Anybody have the answer? A is one example. D, right, all of them. So completion of an I/O event, it'll go to the ready state because it's ready for next instruction. Awaiting its turn on the CPU, it's ready, it's just waiting. Newly admitted process, that means it's there, it's been created, so it's ready to go. So the answer is really all of the above. Okay, next one. Oh, I'm sorry. All of the above. There's the answer. Okay, the process control block. Which one? Very good. It's A. That is correct. Other parts store this other information. So we know the process control block includes information on the process's state. So your exercise is to look what stores the address of the next instruction and so on. So check all these other ones to make sure you know where they are, because you know they're not in the process control block. So it includes information on the process's state. But know what the rest of them are. Again, that's section 3.13. Okay, the list of processes waiting for a particular input-output device is called a blank.standby queue. Ready. When anything is waiting, that means it's ready to go. So the answer here is B. So know what the other ones are. Look them up in section 3.21. Okay, a blank saves the state of the currently running process and restores the state of the next process to run. Very good. That is context switch, correct. We already did a question on that too. That was your first exercises for this week. But again, look what the other ones are. We have other answers here, but find out why they are not the answer. You'll just know that much more. Okay, example question for section 4.11. Now we're moving to chapter 4. P thread refers to very good. A specification for thread behavior. So again, go through the other answers, look them up to understand what they are. Again, 4.1.1 has your information. The blank multi-threading model multiplexes many user-level threads to a smaller or equal number of kernel threads. So we start talking about multi-threading, multi-programming. Exactly. So know all these different models. So I don't know about many to some. I don't think that is a model. But there's many to one, one to one, many to many. If you've looked at any databases, this is another area where these kind of models are used. It's in relationships. And this multi-threading is type of a relationship. How does one connect to another? What do they connect on? What is the key field, in other words? So I don't know, have you ever done any databases? Any database programming or any classes on databases? Anybody? Okay, not yet. Okay, then this will be very familiar to you then when you come into databases. Models are used very clearly. These are all usually in high-level designs for anything in a computer. Because when you have something in a computer, you have to be able to access it. You always have to have a starting point. So when you have a starting point, then you have to know where the rest of them are off of this point. And again, you're always going to have, many points, then maybe we'll have one, or one to one, or many to many. So this is a very popular model in various aspects of the computer. But we now know this as a thread. But if you think of a thread as just as an object, it could be any kind of object, then these models apply no matter what object you're talking about. If you're talking about threads, or if you're talking about tables or databases, etc. So it's many to many model. And the key here is multi-threading. You know it's more than one. And you see the many. Many user-level threads to a smaller or equal number of kernel threads. So if it's an equal number, it would be the many to the many. Because if you have many, then you have to have many threads, kernel threads. Okay, which of the following would be an acceptable signal handling scheme for a multi-threaded program? I don't know, are you looking at for A? Are you giving A already for this answer, or the A was for the previous question? Again, if you have your book in front of you, you can look it up. All of the above. So deliver the signal to the thread to which the signal applies, deliver the signal to every thread in the process, deliver the signal to only certain threads in the process. Well, that's just like giving messages. If you think of giving messages to somebody, when you're giving messages to somebody, well, you might want to give messages to the entire group, or you might only want to give the message to some of the group, or you only want to give the message to one person. So again, try to relate these objects to a real-world scenario and how it is fit, because more than likely it's going to fit the same way. Remember, we're all trying to make the computer simulate the real world some way, from using devices to using applications to using processes. Processes and programs are our way of using the computer for our real world. So if you put everything in that concept of the real world and substitute thread for person, you may be going to get a better, clearer idea of your answer. Again, look at section 4.62 no more. Which of the following statements regarding threads is false? Sharing is automatically provided in Java threads. Both pthreads and Win32 threads share global data. The start method actually creates a thread in the Java virtual machine. The Java method join provides similar functionality as the wait for single object in Win32. Now that's something you're supposed to just have read. You're right, we didn't, there was a lot of information there. So I'm glad I'm bringing it up. It gives you an area then you need to go over and look again and review, especially before you take the exam. So know the difference between, or how they're all connected between pthreads, Win32, and Java. But sharing is never automatically provided because you may not share. This is Java. Java is going to be used to create all kinds of possible strategies. And remember we discussed, sharing you can, but sharing may not be done. So if it cannot be done, that the Java thread cannot provide it automatically. It has to be an option that's set. We already know, sometimes sharing is there, sometimes it's not. But as we look at the next one, we should know that threads share global data because it comes from a parent process. Again, put it in the order of object-oriented programming. We know a thread comes from a parent. Somehow there's a parent involved. And when there's a parent involved, there's always some global data involved with a parent. That's part of inheritance. Start method, well, you just have to know that. So the start method actually creates a thread in the Java virtual machine. You just, again, it's just knowing syntax, and it's just knowing, you know, what programming languages use for their syntax. Same thing for join. So there is discussion on this in section 4.4.1. Okay, according to Amdahl's law, what is the speed up gain for an application that is 60% parallel and we run it on a machine with 4 processing cores? This is kind of a good lead-in to this coming week because we're going to be looking at all this process scheduling, and there's always performance metrics that are done. There's some kind of statistical calculation because otherwise, how do you know what you have going is good? Or how can you gauge what hardware you have is good? So there's always objective, quantifiable information or values that can be calculated to generate statistics, benchmarks. There you go. We got an answer here. Yes, 1.82. And here it is. Here's Amdahl's law. Now, I don't know how strong you are in math. We will be, again, a lot of processing to determine processing times or speeds. You're going to be using values, and you're going to use equations, and you're going to use calculations. So it's just a matter of knowing them. I don't know if you can logically or kind of make an analogy to this to try to understand it, but there is a good discussion in the textbook, so you can go through your textbook then to understand this further. But it's a matter of if S is the portion of the application that must be performed serially on a system. Now, why are they looking at serially? Because serially is what we, by serial means in sequence, is what we have to wait for. We can't count it if there's 4 instructions and all 4 can be done at the same time. So it really only counts for the time for one of them and the one that takes the longest. So we know for sure whatever has to be done in sequence is what will help or determine the speed. So we're looking at speed. So 60% of it's parallel, that means 40% is serial. And there's the calculation according to the Amdahl equation. So it's a number you can play with. Well, what if I have 5 processing cores? Why is it 60% parallel? Yes, your answer is correct. Good guess if you guessed at it. Maybe you just have math. You may have, your brain might be like a mathematical calculator. But in general, how does it determine what's parallel? Well, that would be looking at the instructions. What instructions can be done at the same time? What, you know, how can these processors be working together? I mean, you have time getting information to them, actually them processing. So it's all a matter of the kind of processors you have, what their abilities are, and again, it's what you have to do in sequence determines the length that it takes. Even though you might have 4 at the same time, it's still those 5 that you have to do one by one that determines your speed. Okay, so those are a little review on chapters 3 and 4. If you have any questions, you can go over the material, bring it then to the virtual classroom. We can revisit it then. And again, use these slides as review sheets, add information, add your notes so that you can have, you know, an overall understanding of all the materials. There's a lot of material, so you need some kind of tool or some kind of help in creating your own little study guides. Okay, so process scheduling. Now this is we're only going to go through this one chapter, but that's because there's a lot of material here. Again, we're doing an overview of operating systems, so we're going to look at all things possible. If you're just looking at one operating system, then you have a subset of that operating system and the strategies that operating system uses. However, we're going through all possible. So, CPU scheduling the task of selecting a waiting process from the ready queue and allocating the CPU to it. In other words, passing the instruction to the CPU. How do you determine what to do? I can have a long program and I can just do one instruction at a time, but that will defeat the purpose if I have many processes waiting to continue. That's why on the announcements page I have that little clip. It's kind of like a cartoon about first in, first out, what that can do. So there's different strategies. And again, you're going to pick which strategy you need to determine how you need things to go. Sometimes you will have a mix. You'll have a mix in the sense that, okay, maybe it's first in, first out. However, I have an emergency, so I need the CPU now. So then I might break into that strategy and put mine in there because it's an emergency, it has to be done. So let's look at, we're going to look at the most commonly used criteria to compare CPU scheduling algorithms, including CPU utilization, throughput, turnaround time, waiting time, response time. And you will study a variety of scheduling algorithms in this chapter. That's why that first discussion question we are doing is just first get a list of all of them. I think that's a good start. Get a list of all the possible process scheduling strategies, and then from there, understand what each one does, because there's a lot of them. And on top of it, many contemporary computer systems support multiple processors and allow each processor to schedule itself independently with processor affinity, load balancing, and multi-core processing must be carefully considered. So yes, we have sophisticated technology. We have sophisticated hardware. Now, how can we keep up with all this hardware? Sometimes we have wonderful hardware and technology, but it's keeping up with that hardware and technology with the software that we kind of are lagging behind. Really, the processor is very quickly, but we can't even get our instructions to the processor as fast as that processor can schedule it. And then if you're going to add more processors on top of that, the speed, yes, is phenomenal, but it's getting the information to these processors that we are lagging. So we have some that are faster, some that, again, depends on the environment, what it is you're doing, what you need your computer system to do. If it's real time, it's different than if it's batch processing. So here are the topics for Chapter 5. We have basic concepts. Yes, there's going to be a lot of math. Again, we're going to be talking about statistics. It's all, a lot of it is just statistics, because you got to calculate time, speed. And that's how you consider a strategy in scheduling. Why? Oh, that's just welcome to the world of systems programming and operating systems. But again, you're going to have multiple choice questions. There is a lot of material between all the chapters you're going to have. So as the amount of questions that you will have that are mathematically based, you know, will be a few. It won't be the majority of the questions because there's so much we are learning and there's so much we're doing. So you have basic concepts, scheduling criteria, scheduling algorithms, thread scheduling, multiple processor scheduling, real-time CPU scheduling, examples, and algorithm evaluation. Well, this is what PhDs are made out of. If you're going on to get a doctorate or a PhD, this is the depth you will take into this process scheduling. They have to, when someone offers you a schedule or a possibility for a schedule, they have to verify and prove to you why it's better. And again, the universal language is mathematics. And the computer is a machine that does calculations, or it works with signals. So it is all mathematically based. So that's why you have a lot of mathematics. But again, you could be a systems programmer or you could be applications programmer. You don't have to deal with all this if you do not want to. There's a lot of areas in the computer technology fields that don't concentrate on this. There are many who do concentrate on it. You can go into algorithms and all kinds of theoretical algorithms that are mathematically based. So it all depends what you like. If you're a natural at math, then maybe you want to go that area, that route. If you're not, then maybe you don't want to go that route. Okay, so week 3 processing schedule. Obviously, you're going to read Chapter 5. There are some videos. So do make sure you do that, and do it before the virtual class so that you'll understand things when I talk about it, or if you have questions, you can ask them. We will have the virtual class on Wednesday. And also, I want to repeat this. Again, they are making, obviously we know it's required, but they are taking it to the extent that they really want you here. They will come into the classroom and monitor who's there and who's not there. So only in extreme emergencies, it's, you know, if you can't make it, you can't make it. If it's an extreme emergency, then you could do the substitute. But, you know, not many extreme emergencies really occur, and hopefully none do occur to you. We don't want things like that to happen to you. So try to make it if you can. If not, you know, there will be the recording. There will be the recording of this as well as the classroom. You can always review it. And then if worst came to worst is a real emergency, then give me that substitute assignment, is where you give me a summary of the presentation after you review the recording, and email that to me by Saturday. But hopefully you'll be able to make it. Okay, so the discussion question again, we're talking about process scheduling. Again, when I have these discussion questions, that's for you to start then formulating all the information so you can now put it in a file. Have it when you're going to study for the exams. Again, a good strategy is to first understand all the possible scheduling processes that are out there. And then once you get the list, then you can go through it and then understand the differences and what each one is about. So since it's a lot of material, at least start with the list and start going from there. And then little by little, you'll be getting each of those. By the end of the week, you'll know them all. And then here's your exercises, 5.5, 5.14. And again, you have that Dropbox. So I will then grade it from the Dropbox. It is due Saturday, but I do, again, ask you politely and nicely that don't do a disservice to your classmates. If you'll give me the assignment early and I give you my feedback and answers, don't just give it to a classmate so they can copy and paste it. You're not helping your classmate learn. Okay, they have to understand it too so they can answer it. You can all discuss it, post information about it, but don't just give the exact one. Good question. Okay, since I'm an expert in operating systems, you think 14 weeks are enough time to understand all chapters on our material perfectly? Yes, it's a good foundation. Yes, you will be familiar with all of it. But you have to put the work into it. But one way to do this is through repetition. Repetition is the key. That's why I always say, I'm giving you practice exercises to start thinking about it. I'm giving you discussion questions to start putting down answers. You will read these things. Yes, you can. Again, it's a matter of repeating and going through the material till you get it. That's why I read all the material, because you're going to get exposed to it. Right now I'm giving you some information about it. And then you're going to read the chapter. You're going to look at the videos. Okay, so you're going to start learning it. And then on Wednesday, I'm going to go over it again. So you're going to learn it again. And then on Saturday, you've got to do your answers to the questions. So you're going to learn it again. So you've got to have 4 opportunities to go through this material. You know, if you didn't get it the first time, well, you got a second chance, third chance, and fourth chance. And not only that, when you're going to come to the exams, you're going to review it again. So that's 5 times. When you come to the final, you're going to review it again. That's 6 times. So when you're going to go through this material 6 times, I think it'll build up as you go through it. You're going to get most of some of it, you know, in the beginning, more when you revisit it again, and then you'll know all the basic stuff. You'll be able to go to the details. So yes, you can. And the reason why you think you might be missing something is only because there's so much. But really, you do know more than you think. I always tell my students, look backwards. Look at how much you used to know, and look how much you know now. And also, do know that you don't have to get everything the first time. Yeah, it does take a lot of time, that is correct. But again, you have the extra chances, okay? You have the week when we're discussing it to go over it, but if you're busy and only you can get some of it, that's fine. You're going to have to look at it again when you study for the midterm exam. So you look at it again, you're going to get some more. And then you're going to study it again when you go through the final exam. So you're going to get the chance to learn some more. So you don't have to get everything the first time you go through it. You will have an opportunity to go through it again. So maybe yes, no, you will not get it the first time through. But remember, you have many opportunities to go through it again and again. So do as much as you can when you do it. And get a good routine, being online. You can't wait for this big block of free time all of a sudden that you could do everything. That big block will never come. Or if it comes, you know, maybe it'll come, maybe it won't, because you have other things that interrupt it. Just like an operating system. Think of yourself as an operating system. So find a process schedule for yourself that works in your life. But visit it every day. Every day look at something. Do some reading. Okay, look at some posts. Look at some videos. If you do a little bit every day, believe me, then by the end, you will get it. There's a lot of material, but it's not that much. But you have to do at least a little bit every time or every day. So make it a daily routine. I'm sure you check your email or your social media sites. You will, like I said, get the basics, and then you'll say the next time through, you'll say, aha, now I understand it more. And then when you go through it again, you'll say, aha, I understand it even more. So the more you visit it, the faster you'll get it, and the more you will get. So even if it means a little bit every day, that's fine. Or do more every day. But the more you put into it, the more you get out of it. So those are basic. But again, like I said, and some of this will be visited again. Remember in chapter 1, we talked or 2 and 3, we started talking about process scheduling. We visited it already. And now we're visiting it again. Same thing when we're going to go through other chapters. We already talked a little bit about it. So now we're just going to talk more. So a lot of material is repeated and it's just added with more detail. So as you go through it, you will get it. So I know you will. You are a great student. And don't get stressed about it. Getting stressed or anxiety, that will keep you from learning. Just tell yourself, I'm just going to learn what I'm going to learn today, and that's it. I don't have to learn everything. I'm just going to learn one section. So break it up into small parts, and then you're going to feel better. And go to the classroom every day. Because if you miss a couple days and then go, then you get overwhelmed because you're going to see so much. And then you see, oh my God, how am I going to do all of this? So if you do something every day a little bit, you're going to feel better about yourself, and then the material is going to come easier to you. And by the end of week 14, you'll be all expert. You are quite welcome. And bring in family and friends to help you. Say you have family and friends, you're busy doing something, well, take your computer to them and say, come on, we're all going to learn about this. And start explaining it to them. Even though they might not understand what you're saying, but at least show them some pictures. And then you can bring it into your family event. Bring it to the dinner table. I don't know. Okay, just some strategies. Make it as a fun part of your life that you can bring other people into it so that it's something that everybody shares and understands. It's important. The more people that support you, the better it'll be for you. And make them support you. Okay, so the discussion question, what are the various methods that I use to schedule classes? processes. Again, this is the start. Get a list. Just make a list of them. Go through the book and start. Again, it's like actually how you program. You get a general idea, and then as you go through, write your program, you get more detail, more detail, more detail. That's the same thing with learning a material. Get a general, then little by little, add more detail, and then review it all. So it'll break it up into smaller pieces. Okay, here's exercise 5.5. Someone mentioned math. Yeah, you're going to have some math. But we will go over this in the virtual class. And it's not so bad like you think. But remember, math is not entirely this course. This course has more stuff than this math. So if math is not your thing, don't worry about it. You still can do well in this class. And then 5.14, this is your next question. Again, try to relate this to the real world. When you think of a CPU, you know, relate it to the real world, and sometimes everything will fall into place. When you start switching out the CPU or computer hardware into something that you experience in real life, then it will fall into place. Remember, we are taking the computer to do our real world stuff. So there really is a wonderful relationship. So if you could bring that analogy even to how a computer works, you know, bring it to the analogy of maybe the human body, how the human body works, you know. So make some connections in the real world, and that way it'll kind of flow easier, maybe. You don't have just strange words or strange symbols related to something you're familiar with. And again, if you don't understand the textbook, go to the internet. There's a lot of other resources. Go to the library. There's other resources. Maybe you like just seeing a video. We have some videos in the classroom, but maybe you like to learn the other stuff in videos too, because reading it's not making sense to you. Then go get some more videos. Okay, this question is easy, I think. Well, you could take a stab at it. Oh, no, wait, that's an answer. Okay, well, wait. Bring it to the discussion forum. We'll talk about it. And I do have some optional ones. So I have some optionals, I mentioned. I'm going to bring you extra ones to help you prepare for midterm exam and final exam. So these are some extra ones for you to do. We'll go over them either week 4 office hour or the virtual class, depending how much time we have, but something for you to look at. And then again, I'll post these slides in the discussion forum for you. This is recorded. You can review it again. And then we will have the virtual class on Wednesday. So make sure to go through the material. You have Monday, Tuesday, Wednesday, 3 days. 3 days to go through the material. Go through something, some of it. So that when I talk about it, you're going to say, hey, I know this already. That's the whole thing, is building confidence. And you will build that confidence if you look back. How much you used to know, how much more you know now. So pick up the easiest stuff right away that makes sense to you. Then later go back to it and get the more difficult stuff. It'll be easier once you understand the basics. So I know you're all good students. You will get it. And it's just a matter, again, visit the classroom every day. I think that's the best strategy. Do something every day. Then you won't feel behind. You'll feel like you're in control of it all. And involve your family, your children, your friends, your classmates, and it makes it more fun. Okay, so any questions so far? I think we're kind of at the end of the office hour here. Thank you for coming. We will see you again on Wednesday, or you will hear me. And again, I will post this in the discussion forum, and also you have the recording in case you want to see it again. And again, thank you for coming. All of you who are here right now, for sure you are already good students because you're here. So yeah, you're going to get it because you do things like this. And don't hesitate, if you ever have questions or you need some advice, anything, contact me. That's what I'm here for. Or contact your classmates. That's what they're there for. We're all together on this. Okay, thank you and have a good day.
Recording stopped.